Hello everyone, welcome back, and today we are looking at question 371, which is sum of two integers. So we are given two integers a and b, and we want to return the sum of these two integers without using the plus and the minus. Okay, now so example 1 is saying a equals 1, b equals to 2, 1 plus 2 equals 3. Now example 2 is saying, okay, we have a 2, we have a 3, and 2 plus 3 equals 5. Now we know how to add numbers, but the challenge is we want to do that without using the plus and the minus operators. So how can we do that? Well, let's go to the blackboard. We will explain exactly how can we do this. We will explain the approach and the intuition, and then come back to LeetCode to code the solution out. If that sounds interesting, let's get straight into it. Okay, so to start this question, let's go to the basics on, we want to add some numbers. So we have, for instance, 2 plus 3. We know that 2 plus 3 equals 5. 4 plus 4 equals 8. Now, 11 plus 19. What do we do? Well, 1 plus 9 equals 10. So we have a 0 and we have a carry right here. Then we say 1 plus 1 equals 2 plus 1 equals 3. So the answer is 30. Now, it's important to note that these numbers are in base 10. Base 10 means that all the numbers that we are allowed to use go from 0 all the way to 9. Now, that's why in this question right here, when we say 1 plus 9, well, we know that the answer is 10. But since we are in base 10, we are not allowed to use this number because it does not exist. All the numbers that do exist in this base are from 0 to 9. Now 10 is greater than 9, so it does not exist. That's why we have the carry over. We put the 0, then we carry a 1, and then we continue normally. Okay, so this is important. Now, this is base 10, so let's look at base 2. These are the binary representation of these numbers. For instance, 2 is 1, 0, 3 is 1, 1. 4 is 0, 1, 0, 0, and so on, so forth. Okay, now before we tackle this, it's important to note that whenever the question wants us to do the basic arithmetic operations, for instance, we want to add, subtract, multiply, or divide, right? Whenever we want to do one of these without using the sign, it's always bit manipulation. Now, this question wants us to add two numbers without using the plus sign, so of course it will be bit manipulation. Now when we say bit manipulation, we will be dealing with bits, and we know that the bits are zeros or ones, so that's why we are dealing with base 2. Base 2. In base 2 means that there are only two numbers allowed in this base, which are zeros or ones, and that's it. Now the idea that if we add two numbers and the result is larger than, the biggest number in the base, we will have a carry over. Same thing here. If we add two numbers and the result is greater than 1, we will have a carry over. That's why in base 2, it's always good to keep in mind these two numbers, 2 and 3. The binary representation of 2 is 1, 0. The binary representation of 3 is 1, 1. It's important to keep these two numbers in mind, and I will show you why. So let's start with 2 plus 3. 2 is 1, 0, 3 is 1, 1. Now, what is 0 plus 1? Well, it's a 1. Now, what is 1 plus 1? Well, 1 plus 1 is 2, but again, we do not have 2 in this base, so what do? The same thing here, we will have a carry over. Now we see that 2 in binary is 1, 0. So we will take this 0, we will put it right here, and we will have a carry with a 1, right? Then we can add. You can imagine that we have zeros right here, so 1 plus 0 equals 1. Now 2 plus 3 equals 5, and 1 or 1 is 5 in binary, okay? That's why I said it's important to keep these two numbers in mind. Now let's go to the next one. Well, 0 plus 0 is 0, 0 plus 0 is 0, 1 plus 1 is 2. We don't have a 2, so we will put a 0, and we will carry a 1, and 1 plus 0 is 1. And indeed, 4 plus 4 is 8, and this is the 8 in binary. Now finally, let's go to the last one. So we have 1 plus 1, which is 2. So we will put a 0 and we will carry a 1. 1 plus 1 plus 1 is 3. But we do not have 3 in base 2. 3 is equals to 1, 1. So we will put a 1 and we will carry the next one, which will be right here. Now, 1 plus 0 is 1, 1 plus 0 is 1, and of course, 0 plus 1 is 1. Now, this number in binary is 30, and indeed 11 plus 19 is 30. So, the summary of this section of the video is that the addition in any base is the same. We add numbers, and if the result is greater than the largest number in the base, we will have a carry over, okay? So this is the summary of this section of the video. Now let's continue. Okay, so once we understand that, now what do we do? Well, to solve this question, we said we need bit manipulation. Now, which bitwise operators we need to use? Now, when I say bitwise operators, they are operators that work on bits, and thus the name bitwise operators. Now, we will be using 3 of them, which are exclusive or, we will be using the bitwise AND operator, we will be using the left shift operator. Now, why we will be using each one of those? Well, I will explain in details, but let me give you an overview. Now, the XOR, the symbol for XOR is like this, bitwise AND is like this, and now the left shift is like this. Now, why we will be using exclusive OR? Well, keep this in mind. Exclusive OR is used, okay, to simulate addition without the carry. So exclusive OR is used to simulate, okay, addition without the carry, with no carry. Alright, now the AND and the left shift, both of them combined are used to simulate this carry, okay? So these are used to simulate the carry. Now, why and how do we do that? I will show you exactly what to do. Now, to start with, let's have a small review of the exclusive OR and the AND. I will have 2 numbers A and B, okay, and I will put them into a table, and I will put all the combinations of these 2 numbers. A can be a 0, A can be a 1, okay, B can be of course a 0 and a 1, so we'll have these. If we have 2 numbers, we will have 4 possible combinations: 0 0, 1 0, 0 1, 1 1. Now let's do a exclusive OR with B. Now in the exclusive OR, the only way that we can get the 1 in binary is that if A and B are different. In this case, 1 0 0 1, A's and B's are different. We will have 1s right here. 0 0, A and B are the same, we will have a 0. 1 1, A and B are the same, we will have a 0. Okay, I will come back to this to show you how this will simulate the addition. Now let's look at the bitwise AND. We will have the same thing, the same table right here. So let's copy that and let's paste it right here, and we will change these. Okay, now in bitwise AND, the only way to get a 1 is that if A and B both are 1. In this case, only this row right here, 1 and 1 will leave us 1. The rest will be zeros, 0 and 0 0, 1 and 0 0, and this is the same. Okay, well, we said exclusive OR is used to simulate addition without the carry. Now I say with no carry. You might be confused why is that the case. I will show you, just bear with me. We will see that 0 0 give us 0, 1 0 give us 1. So what do we notice? Well, it is simulating addition. 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is, wait, 1 plus 1 is not 0, 1 plus 1 is 2. But remember, the 2 is equal to 1 0. And now when we added these, look at this here, right here. 1 plus 1, we said it is a 2. we put the 0 and we carried the 1. And that's why we said exclusive OR is used to simulate addition with no carry. This will only give us the 0, but it will not give us the carry. Okay, so that's why exclusive OR is used to simulate addition with no carry. Now let's look at the bitwise AND. We see that it only gives us 1 when A and B are 1. Okay, so let's look at a quick example. We want to add 7 plus 7, which will give us, we know, 14. Okay, so let's do that. 7 is 1, 1, 1. So we want to add it with 1, 1, 1. So let's see what happens. So we will have this, and now I will show you how these can work together. 1, 1, 1, and we have the same here, 1, 1, 1, but now with the bitwise AND. And now here I will show you the addition, 1, 1, 1 plus 1, 1, 1. Okay, so now, starting with exclusive OR. Well, exclusive OR will give us a 1 if A and B are different. Here, all of them are the same, which means that this will give us 3 zeros. Now, let's look at the AND. The only way we will get a 1 if that A and B are the same. In this case, all of them are the same, so we will have 1, 1, 1. Okay, so let's try to add 7 plus 7 in binary. Well, we said 1 plus 1 is 2, so 0, and let's carry a 1 right here. Now 1 plus 1 plus 1 is 3. We will have 1, and we will carry a 1, so 1, and let's carry a 1. 1 plus 1 plus 1 is 3, so 1, and let's carry a 1. And 1 plus 0 is 1. And this is indeed 14. Now what do we notice? Well, we know that each number of those will give us, each addition here will give us a carry. And that's why the exclusive OR gave us all zeros, because it simulates addition with no carry. So that's why we are missing all the carries. But let's look at the AND. The AND is giving us all 1s because A and B are the same. Well, 1 plus 1 will give us a carry. 1 plus 1 will give us a carry. 1 plus 1 will give us a carry. So look at this. The bitwise AND always tells us the position that will produce a carry. When we see a 1 here, this means that this position will produce a carry. When we look here, this position is telling us, hey, this will produce a carry. We have a 1 here. This position will also produce a carry. So you see this? The exclusive OR simulates addition with no carries. The AND tells us the position where we will have a carry. So now when we add these numbers, what do we see? We have the carry right here. You see the AND gave us 3 1s. And now we have the 3 1s right here, but they are left shifted 1 position to the left. Now why is the case? Let's go back here and look at this. When we said 1 plus 1 give us 2, we said 0 and we have a carry. We put the carry 1 position to the left. Let's look here. 1 plus 1 is 2. We have a 0 and we carry a 1 position to the left. Let's look here. 1 plus 1 is 2. 0, you carry 1 position to the left. 1 plus 1 plus 1 is 3. We have a 1 and we have a carry 1 position to the left. So we always apply the carry 1 position to the left, and thus we have the left shift operator. So the AND will tell us which position will produce a carry. Once we know that position, we will shift it to the left by 1 so that we can apply the carry. Okay, as you can see, the AND gave us the position where we have a carry. We took this number, we shifted it to the left by 1 position, and thus it's starting from here, not from here. And we just add the carry and we will have the result. And that's how we will do the problem. 1, we will put the exclusive OR of the 2 numbers, which will give us the sum without the carry. Then we will apply the AND, then the left shift, so that we can have the carry that we will add to the result. So let's do one example to see how to do this, then we will go and code the solution out on LeetCode. Okay, so let's try to add 6 plus 6. We know 6 plus 6 gives us 12, and 12 in binary is 1, 1, 0, 0. So let's see how can we arrive to this number without using the plus sign. Well, we said we need to compute the sum using the exclusive OR without, worrying about the carry. So we need the sum, and we said we also need to check the carry. So we will have two variables, one for the sum without worrying about the carry, and one just for the carry. Okay, good. So we said 6 plus 6. Now 6 in binary is 0, 1, 1, 0. Of course, we will add it to itself, so 0, 1, 1, 0. So we have these two numbers. Well, 1, we said we need to simulate the addition without the carry, so we will take the exclusive OR. The only way to get a 1 is that if both of them are different. 0 and 0 the same, 1, 1 the same, 1, 1 the same, 0, 0 are the same. So this gives us all zeros. So this will be stored inside of the sum. Now let's look at the carry. Well, we said we need to do the AND operator, then we will do a left shift. Now in AND, we need both of these numbers to be a 1 to get a 1, which means that 0 and 0 is 0, 1 and 1 is 1, 1 and 1 is 1, 0 and 0 is 0. So this is the carry, but we need to left shift this number to the left by 1 position, right? Which means we will have this number right here, 0, 1, 1, 0. As you can see, we have the same number, but we left shifted it to the left by 1 position. So this will be the carry. Okay, so now we have the sum and we have the carry, and we left shifted it to the left, so the carry is ready to use. Now, what do we do now? Well, of course, we need to add the carry to the sum. What is 0, 0, 0, 0 plus 0, 0, 1, 1, 0? Well, we said to do the addition, we use the exclusive OR. 0 and 0 is 0, 0, 0, 0, 0 and 1 is 1, 0 and 1 is 1. Of course, 0 exclusive OR with the 0 is 0. So here's the answer, 0, 0, 1, 1. And what is this? This is 12 in binary. Okay, that's it. Now, there is one last thing that we need to look at, but we will explain it when we write the code. But an overview of that thing is the following. When we compute the sum, when we compute the carry, then of course we add the sum to the carry. In this case, we got the result. But remember, whenever we add two numbers, right, there is a chance that we will produce a carry. So when we add the sum to the carry, there are cases where this addition will also cause a carry. And we need to keep doing this. We can think of this as a loop that we will keep doing until the carry is 0, so that we can return the sum. It's okay if that sounds a little bit confusing. Let's go to look at the code, and I will explain to you exactly what happens. Okay, so let's try to write the code for the solution. Well, we said we need two variables. We need the sum and we need the carry. The sum will be used from the exclusive OR, so that will be the sum without worrying about the carry. So the sum will be the first number, which is A, XORed with B. Okay, now we need to look at the carry. Well, we said that the carry is basically, we need to take the first number and the second number, apply the AND operation. This will tell us the position of the carry. Then we need to left shift 1 position to the left, so to make the carry ready to use, right? So A, so we'll be using A, let's AND it with the B, and finally left shift 1 position to the left. So now we have the sum, and now we have the carry, and yeah. So now we said we need to add the sum to the carry to have the result. But we also said that whenever we add two numbers, there is a possibility to have a carry. So this sum plus the carry might produce more carry overs, right? We need to keep doing this loop until the carry hits 0. So we will have a while loop, and we will say, hey, while the carry does not equal 0, we need to keep looping. But let me ask you, imagine if we are adding 2 and 3. 2 plus 3 equals 5. And what is the carry? The carry would be 0. So we go here, hey, while the carry does not equal 0, In this case, it is 0, so we break from this loop and we just return the sum. Now let's look at the case where we have a carry. In the previous example, we said 6 plus 6 equals 12. Okay, so here we computed the sum using the XOR. Here we computed the carry, and now we need to add them, right? So we said, okay, this sum will equal sum exclusive OR with the carry. Again, when we need to add two numbers, we apply the exclusive OR. We need to add the sum with the carry, so we say sum exclusive OR with the carry, and we will update our sum. But we said this might produce a carry, so what need to do? Well, we need to check that carry. We said, okay, the carry, let's copy and paste, it's the same equation. The carry, but now we don't have A and B, we have the carry itself, and we have the sum, right? We need to add the sum with the carry, we apply the exclusive OR, but this might produce a carry, so we take the AND between them, and then we left shift one position to the left. So we have the sum, we have the carry, then we go to the while loop, we check, hey, is the carry 0? If yes, we break, we return the sum. If no, we continue. But here there is a small problem, which is the following. When we say sum equals sum exclusive OR with the carry and we update the sum, okay, now when we want to check the carry, we can't say carry and sum. This has changed. This is no longer equals to this. So what we can do is that, okay, no problem, int temp, we can have a temp variable to store the sum. Then when we update the sum, okay, we just say sum and with temp. And that's it. We compute the sum, we compute the carry, we have a while loop to keep going until the carry hits 0 at the end. When the carry is 0, we break, we return the sum. So now let's run the code and let's submit. As you can see, faster than 100%. So now let's look at the time and space complexity. Starting with the space complexity, we did not use any extra space, so it's big O of 1, constant space. Now what about the time complexity? Well, we are trying to add numbers, and it's important to note that each integer is 32 bits. So anytime we will do this program, we always are applying the operations between numbers that are 32 bits. This is a constant. So the time is always big O of 1. The time will always be the same. We have 32-bit integers. So the time is always the same, big O of 1. I hope you guys enjoyed the video. Best of luck to you, and I will see you in the next one.